Hello and welcome to the Healthcare Quality Podcast. And today we're focusing on how to take charge of your transformed data. One of the things that people across the country ask when they get in touch about Lean and Six Sigma is, I got these data and they don't follow a normal distribution. So since they're not normally distributed, I'm not really sure what to do to go ahead and show improvement or change. And so from surgicalbusinessmodelinnovation.com, we've taken the blog entry, Take Charge of Your Transformed Data, and we'll run you through now some of the pearls and pitfalls for what to do with data transforms, when to use them, and how they work. So there's no need to tell you about the importance of data. If we can't measure something, it can be very challenging to manage it. And I've seen many posts that describe why it's important to manage our systems with data. And there's a lot of other ones on the website that you can take a look at that sort of show you the importance of managing things with data. You also may have read about things like Kotter's 8 Steps for Culture Change and other tools like SIPOC diagrams and project charters. One of the most important things that this entry will impress on you is the unique situation where you've done a lot of that background work, you have data on a system, and the data don't follow the normal distribution. So there's no need to kind of go through the background with you if you're tuning into something along these lines and reviewing an entry like this. There's no need to tell you about the importance of data and managing our systems with data. So let's say you're in a situation where you've taken data right from the process, often a continuous data endpoint, and you end up with a non-normal distribution. And the first question is, how do you know data follow a non-normal distribution? And one of these ways is by using the Anderson-Darling test. In another blog entry, you can read up on the Anderson-Darling test as one of the named statistical tests to tell if your data follow the normal distribution or not. So when you've used that test and you've found that your data follow a non-normal distribution, well, the question is often, well, what to do next? And there are several options. One option is to perform a distribution fitting, where you ask a program like Minitab or Sigma XL to go through your data and test it against known distributions. And then it'll tell you, okay, your data fit this known distribution. One of the Poiseuille distributions or another named distribution, just not what's called the normal distribution. And the programs are really good at that nowadays, and it'll test your data set against many of the known distributions. And that's a great thing, because if you can show your data follow a non-normal distribution, you can then say with some assurance, okay, I have this non-normal data set, and now I can use statistical tests that do not rely on the assumption that data are normal. Are normally distributed. One of the biggest issues that we see as we do quality improvement that is very data focused and driven is that staff obtain data and then use statistical tests which aren't really valid unless those data follow the normal distribution. Things like the t-test or other tests of whether there is a significant difference pre and post intervention in the central tendency of the data. Many tests typically rely on, many of the common tests, on normally distributed data. There are some versions of these tests that work for non-normal data. Data that are not normally distributed are amenable to tests like Mood's median test or the KW, Chrysalis-Walsk, I can never say it properly, test for variance. So there are different tests you use when your data are not normally distributed, and that's why it's important to know. So let's say you found a non-normal distribution. Well, your one option is, as we said, to use tests that don't rely on normally distributed data. That can be a little challenging because there are some real oddball tests that aren't used much there. For more information about which tests to use in which situation, where there are normally distributed data or not, you can go to the blog, surgicalbusinessmodelinnovation.com, and you can type in what's called tool time. And that'll bring up an Excel file, which I first saw from Villanova University, so thanks to them, that tell you which statistical test to use in which situation. So one of your options is to use tests that don't rely on normally distributed data, if you don't have normally distributed data. Another test, or another way to treat those data, is with what's called a data transform. And that's what we're going to talk about today, mostly. A data transform is, again, for those situations where your data are not normally distributed. And what you're able to do with that is take your data set and transform it, mold it to a normal distribution. And some of the ways to do that are by taking your continuous data endpoint, like time until a surgeon gets to see a patient, and doing things to it like squaring it, or taking the square root of it, or putting it to the third power, or the fourth power, etc., etc. So these power transforms are ways that the statistical packages take your data set and try it in all these different ways, taking the square root, taking the cube root, cubing it, squaring it, and they report to you what they had to do to it, what power they had to raise your data to make it work, to make the distribution become a normal distribution. And there are different power transforms, and one of the most commonly used ones is called the Box-Cox transformation. And the Box-Cox transformation is a very useful one, and the computer will report what's called a lambda value, or the value to which they had to raise your data to change it to a normal distribution. And after it does that, the computer will take the best way it could find, the best sort of function, and it will then take that data set that it has tried to make a normally distributed, it'll take that output and it will test it with the Anderson-Darling test. And it'll find out, okay, are these data normally distributed now? So if you've ever been in a situation where you've measured a system only to find out the data are not normally distributed, and that happens, you have two options. One is distribution fitting, where you test to find out if you fit some other distribution, or a data transform, like a Box-Cox transformation. Now, these power transforms can create some things that feel strange. For example, let's say we're looking at time until a surgeon can see a patient. Okay. What's interesting is the Box-Cox transformation may say, okay, squaring these data, this time until seen by surgeon, gives you a normal distribution. And that's interesting, but not really intuitive, because what does it mean to manage the square of time? So the challenge is that it creates a situation that sort of feels strange and may not be intuitive. And it's important to impress on the team, this is a statistical manifestation of what's going on. And you're doing that to be able to test for a significant difference pre and post interventions. You're using this power transform to see if you've made a difference after you've tried to do something to improve time until seen by a surgeon. So it's not really intuitive if you end up with something like time squared or time cubed after a Box-Cox, but it's important for the team to learn that it may feel strange, but this is a way that we're setting the data up to be able to tell if we've made a difference. So again, what does it mean to manage time squared? Well, again, it's hard to feel what that means, but it's important to reassure the team that you're doing this to try to demonstrate whether you've made improvement. It's a statistical manifestation, and of course, if it takes a certain amount of time to see a patient, squaring that is sort of in direct proportion to that variable, meaning if it takes 5 minutes to see a patient versus 6 minutes, well, it takes longer it's similar if you square 5 minutes and get 25, and if you square 6 minutes and you get 36. So if it takes longer to see a patient, that square value will be longer. It's just that the data are not normally distributed. In order to be able to use the tests to tell if you're doing better, tests which often rely on a normal distribution, you just had to use this box-Cox transformation, this power transformation. Sometimes certain teams I've worked with, especially if they don't have this background in Six Sigma or Lean that is very data-driven, can think the word transform is almost a bad word. It almost sounds like you've manipulated the data. And when I say manipulated, I mean manipulated in the bad sense, that you've left data out or you've somehow cheated the system. But transform and manipulated in this context is usually just means to change. You've changed the form of the data really rather than the content, and you've sort of set it up to then be amenable to using different tests. So it's very important to my mind to say, call it data transform, but you're not changing the data so that they somehow lack meaning or their meaning is subverted somehow. You're doing it in a way that sets the data up for later statistical testing to highlight whether you have or have not made a real change. So when we're in a situation where the data are non-normal and don't follow any typical distribution, you've maybe even tried distribution fitting and it doesn't follow any typical distribution, that really almost leaves you with one of the only options as a power transform or a box-Cox transform. And I encourage you to focus the team on the fact that you're comparing, you're changing the data in the sense that you're changing its form so that it works with statistical tests. It's really important, to my mind, to highlight what transform and manipulate means in this case. So keeping the team aligned with Reassurance is key. And in the end, we find that typical issues with managing system variables like time squared go away when we focus the group and do some education. If you've done a Lean Six Sigma training as a black belt, you probably learned about some of the non-normal data statistical tests and power transforms. So let me encourage you to let the team in on the knowledge if you have that, or to go find it yourself if it's something that you haven't seen before. And one of the sources is our blog, surgicalbusinessmodelinnovation.com, which focuses on this and other issues. And remember the resource of Tool Time, which has each statistical test, the situation that you'd use it in, and those ones that are commonly used for process improvement in healthcare. Thanks so much for your time today, and hope you found this entry useful. Remember, for questions or comments, visit us on surgicalbusinessmodelinnovation.com.